All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are gonna continue. Um, I was about to say we're gonna continue learning about the Transformers library, but no, we're not gonna be doing that. We're gonna be using the Transformers library. We're gonna be exploring um, the usage of the Transformers library. We're gonna try and load up some models and run inference on them and try and get the output from them and stuff like that. Now, here's the thing. I do not know how long my system is going to remain stable because, um, well, uh, how do I explain this? So, I have like my system it has this thing where every now and then I will have the UI kind of freeze up and become unresponsive, and then I'm only able to the only thing I can do is restart the system to fix that issue. And just my luck, everything was running fine. Everything was running great until half an hour before I decided to start up the stream. Like half an hour before when I was going to start up the stream. And I noticed it a little late. And so I didn't want to restart the stream because that was going to introduce another extra half an hour or 45 minutes of delay, because sometimes I have to restart the machine once and it might not restart properly. Then I have to restart it again. And then when it finally restarts, I have to wait for it to stabilize. And then eventually I can open up, all the things that I need to open up. And yeah, it takes some time. So I didn't want to restart it. And so instead, I tried to switch windows. Fortunately, Alt Tab is still working, even though I'm not able to use the mouse to click. I can move the mouse cursor around, but I can't really click on any UI components, so I can't select a window from the taskbar, but I can Alt Tab to switch windows. And similarly, I just noticed when I went to start the stream that I wasn't able to click the start streaming button in OBS. So instead, I started using Tab to finally, get the focus, as in Tab, move the focus using Tab, move the focus from one UI component to another, to another, to another, until I finally reached the start streaming button, and then I hit space to start the stream. And I just realized that I don't know if I'm able to interact with the website, because like website stuff, they're links, right? It's not UI. So to a certain extent, I should be able to do it, I think. I'm not sure, but that's fine. Even if I'm not able to use the website, let me try refreshing this page. And let's see if it lets me if it lets me like click on any links or anything. Even if it doesn't, that's fine. The whole idea, like, at least in terms of running these models and stuff, all of that is happening on a different machine. The only thing that's being done on this machine from which I'm streaming is we are showing the video of it. Uh, yeah, I'm not sure if I can click on any of these. It doesn't seem like any of these are clickable, which kind of sucks. But I mean, it is what it is. Fortunately, I did set up OBS before, any of these problems started. So the windows are, the windows have been set up. So I don't need to worry too much about that. If the windows weren't set up, then I would have a real problem. Then I would definitely have no choice but to restart the machine. Anyways, dude, enough of that. Let's get into, hold on. Let me open this up. Yeah, let's get into using some of these models. Give me a second. What conversation did I have open here? Let's break down the questions. What was the question here? Okay, you mentioned using an HF Oh yeah, I had a good set of questions here. I just remembered that. There's also okay, here's something we can do. Okay. I wanna run hold on. Is it here? No, it's not here. It's here. Over here, I need to where was the conversation? Oh, it's an empty. Right. So let's try that. So scratch stuff, empty, Gemini, no, auto clipper, auto clipper Gemini info. There you go. I did not mean to open this in NeoVim. I wanted to open it up in Frogmouth. Okay, great. So we have our information here. Right. And then we have this. And then finally we have, hold on. I asked the question, okay, could we go, oh yeah, okay, this is where I asked it to go over the entire thing again because I'd asked it another question here, which was regarding the timestamps or regarding the result of the ASR, the automatic speech recognition, because when you do automatic speech recognition, it gives you essentially a transcript, and the transcript contains all of the text from all of the text that it has, recognized from this whatever audio you gave it. And so I was wondering, shouldn't there be, timestamps attached as well? Like, how is it gonna? Is it just gonna be like one big blob of text, or is there gonna be timestamps attached? And well, yeah, there will be timestamps attached. So that cleared up that doubt. And then we go into the actual thing. So first things first, we need to extract the raw audio stream. Oh yeah, I need to do that. I do have FFmpeg installed here, I believe. Let's do it here, I guess. dpkgl grep, because I'm pretty sure I installed FFmpeg from, yeah, I have it. Okay. Uh, okay. So we can use FFmpeg to split up the audio. We are not going to use the library so far. Actually, I could try asking. Yeah, I'm wondering if PyAV would be helpful for this purpose. I could try asking a quick question to Gemini in another conversation. Hold on. Let me open up a separate tab. I'm not going to do this like through Gemini CLI. I'll do it through the web interface because that'll just be a lot faster. I also discovered something about updating Brave. So for a while, I'd had this issue with, oh God, dude. Hold on, give me a second. There's something I need to. Uh, okay, now that that's done, now we can do it. Okay, for a while now, I had this issue where Brave would refuse to update. And I was like, okay, could it be that maybe now their stuff is being hosted on like a different server than what the apt system knows about? Because within apt, you can register a bunch of repos where it's going to check for like updates and stuff. And so I was like, okay, is it possible that the location has changed or maybe something else has changed that's caused my information to be outdated? But because I had to manually enter, because for certain Ubuntu applications, I think in other Linux applications also, or in other Linux distros as well, you do tend to have this thing where you would have to manually add the location of for the source, like the repo where the application is hosted, just so that it's not having to be hosted by Ubuntu officially. It's being hosted by whatever developer you trust, and they're going to give you some kind of link that you have to then register with your apt program. And there's another thing that has to do with keys. I don't fully understand that, but what I do understand is that it has something to do with security. So it is a necessity. So my guess was that both of these things might have been outdated, because and I had a conversation with Gemini about this, where Gemini explained that, okay, it's possible that maybe previously you were using a different mechanism to add the key and to add these sources. And because of that, either the key or the sources were kind of outdated, but like that didn't break anything. It's just that over time, Ubuntu, they switched to a different mechanism, a different way of doing things. And the older way didn't break, it just got deprecated, so it's not being used anymore. And that's why your Brave installation didn't necessarily break. It just never really saw a newer version of Brave. So each time you went to run the update, it would just say, yeah, you're on the newest version. The problem is I wasn't on the newest version, but like that was the reason why it was saying that I was already on the newest version. But I would really find out if I am on the newest version go when I would actually open up Brave, because then Brave, it's able to talk to its own servers and figure out, oh yeah, this is an older version. So anyways, I went to the Brave website, and I looked at the installation instructions, and I re-added the keyring thing and the sources again. And then this time, when I tried to do sudo apt install Brave, rather than reinstalling, it just upgraded the version that I currently had. So basically, it did the update that I had been looking for this long. And now I think further from this point, because now there's updated sources, further from this point, we should have proper Brave updates. Yeah. Anyways, what was I gonna ask here? Oh, okay. Hey, so I'm planning on making an auto clipper app in Python. I believe I've had a convo or two with you about this through both Gemini Web and Gemini CLI. I have a little FFmpeg related doubt that I would like to clear. But first, can you tell me what all you remember about the project? If need be, I can just describe it all again. Give me a second here. I just realized that I forgot to open my stream on my phone. Oh, the response is here. Okay. Gemini said, wait just a second. Okay. Gemini said, I remember our previous discussion. You were looking into how to use FFmpeg to slice out specific sections of an MP4 file. I actually did have this conversation with Gemini. Yeah, I remember this. I was trying to find the command to slice out one section of one section of like a longer video and just like export that small section, that small slice as a separate video. I think, okay, no, what Gemini is remembering here is a little different. Okay, I'm gonna be honest. I think you probably might not remember the convo about the auto clipper because that whole convo involved using HF transformers to load a bunch of models to figure out what parts of a longer VOD to clip. I do still have that FFmpeg doubt. Should I clear it or should I ask? I'm just trying to jog the memory. I see we did talk about HF Transformers library and how to use it for non-NLP tasks, which perfectly explains how you're planning to identify those clips in a long VOD using AI models like audio analysis. For excitement or vision models for key moments. So the full picture is you're building a Python app that uses transformers to analyze, yep, okay, there it is. To analyze VODs to find the highlights and then use FFmpeg to actually cut those highlights out. Definitely ask the FFmpeg questions, whether it's about handling stream mapping, concatenating clips, managing variable frame rates, or dealing with those pesky keyframes during the automated cut. I'm ready to help you. Clear it up. What's your doubt? I'm wondering if I should be using a Python library, or I should say a Python wrapper around FFmpeg so I can do the slicing slicing, splitting, etc. from within Python code, or if I should be using, hold on, should be using something like, what was it called? Subprocess? Process. Subprocess. Submodule? No. Hold on. Let me look that up. Because there was something called popen, but wait, okay. Python subprocess. Subprocess run. Okay. Where was I? Wait, where's the conversation? Oh, here it is. Or if I should use something like subprocess to invoke the commands with the required arguments. Okay, hold on. Okay, this is a classic developer's dilemma when working with FFmpeg. Both approaches have valid use cases, but for an auto clipper app, when you are already using heavy libraries like transformers, the decision usually comes down to how much control you need over the pipeline. Here's a breakdown of the two paths to help you decide. Using subprocess, the direct approach, this is generally the recommended way for a project like an autoclipper. You essentially write the FFmpeg command as a string and execute it via Python's built-in subprocess module. The pros are there's no overhead because there's no extra dependencies to manage or keep updated. You have full power. You have access to every niche FFmpeg flag. Wrappers often lag behind FFmpeg updates or omit complex filter graph features. Easier debugging. You can print the exact command being run and paste it into your terminal to see if it works. Okay. The cons are verbosity. You have to handle string parsing, list building, and error catching manually. Platform issues. You have to manage pathing. Example, ffmpeg.exe versus ffmpeg yourself. I did not consider that. Yeah, I actually did not consider that because I'm only ever going to be running this on Linux. But I am planning on distributing this as well, so I should kind of take cross-platform ness, cross-platformativity. No, cross-platform support. Let's just say that cross-platform support. I should take that into account. Now, if we are using subprocess, we are able to specify it in a very simple way. Subprocess command subprocess.run. Okay. Check true. Using a wrapper. Wrappers like FFM words. Wrappers like FFmpeg Python. Fuck me. Allow you to build FFmpeg commands using a fluent Python syntax. Give me a second. Okay, wrappers like FFmpeg Python allow you to build FFmpeg commands using a fluent Python syntax, chaining functions. Pros, complex filters. If you eventually want to overlay text, merge clips, or add watermarks, wrappers make filter graphs much easier to read than a massive string of text. Type safety slash linting. Your IDE can help you with autocompletes for some arguments. Okay. Then cons. Complexity. Sometimes simple tasks like copy become more confusing in the wrapper's syntax than the raw command. Maintenance. If the wrapper library stops being updated, you're stuck. True. Okay. Okay. True. You know what? I think I think I need to make this I think I need to make this modular. Like I'll create a separate module that handles this work, that handles this functionality, and I'll from my side I'll try to make it um, wait, hold on. Okay, yeah. What was I saying? Yeah, I think I'll make it I'll create a sort of like abstraction layer, or I don't know if I should call it abstraction layer, but I'll create for now I'll call it abstraction layer. Okay, I'll create an abstraction layer where you are able to just call one method, and then internally I can change what the implementation is. Yeah, yeah. I could maybe provide a flag where it could be like, okay, um, I feel like I might be overcomplicating it. Though I kind of want to engineer the I kind of want to set up the API in such a way that if need be, I can introduce modularity to it later on. So um, maybe I can change the implementation how a certain, so like I'll create a sort of API that can be called, and then the actual implementation of what's happening when the thing gets called, that'll depend on the flag that you choose. So if you choose the flag can be what's the two different methods that's going to be used. One is subprocess and the other is ffmpeg Python. But then, okay, hold on. Let's see. Okay, there's a little table that Gemini has given me here, which says if your app primarily does simple slicing slash cutting with copy, then use subprocess. If it needs to stitch 20 clips together with transitions or overlays, actually, there's a separate thing that I might need that specific thing for. But for the time being, no, I don't need that. But yeah, if it needs to stitch 20 clips together with transitions or overlays, then use a wrapper. That makes sense. If it needs to be lightweight with minimal dependencies, then use subprocess. If it needs to handle complex audio slash video filtering logic, then use a wrapper. Okay. Oh God. Hold on. Did we? Okay, I think we're still live. I think we are good. Yeah, we are still live. I think we're good. Yeah, yeah. Okay. Um, so I need to think about how I'm going to be going about doing this. Like, what exactly are we doing here? Right? First things first, we need to be able to split this video into, two separate, so like into a video file and an audio file. Then we need the ability to slice. We need the ability to slice audio clips out and like send things and stuff into what we need the ability to slice out various clips and send them into, you know different models if need be. But like I kind of like got confused there because I was like, hold on. Oh yeah, we still need to do that. Yeah. Okay, I just realized that. Yeah, we still need to do that. Because here's the thing, right? For each um so like initially, wait, we need to look at this. So first things first. So we're going to need three types of inputs, okay? Wait, hold on. Yeah, okay. So we're going to need three types of inputs, right? We need video only, we need audio only, and then we need audio video. So video with audio. The video with audio part, I'm not entirely sure if there are any models that I'm going to be sending that into, but there are definitely models in which I'm going to be sending only audio and only video. And initially from only the audio, we're going to generate a transcript. Actually, okay, once we have the transcript, I think for a given transcript, we can like, okay, we can pass in the video and the transcript and then say, okay, now based on this, though I think for that we might need a some sort of vision language model. I think so. Yeah, I need to I guess that's a more advanced use case. We can look into that. So, uh our input, it says here your Twitch VOD, right? Oh, this is all part of the pre-processing. Yeah. Okay. So the input is going to be the Twitch VOD. The VOD is going to be split up into a separate video, separate audio, and we're going to also keep the VOD as it is intact as well. So then we have three types of inputs for our model, our models, because there's going to be multiple models being used. So that's our base input, right? Next, now, okay, this step one, it's saying that the output is going to be an audio file and optionally a sequence of image frames. So I'm going to change things up a little bit. I'm going to make it so we have three separate types of inputs. One is definitely the audio file. The other is only the video file. And then the third one is the entire, you know, um, audio with the video. Right. Next, we have speech to text transcription with timestamps. This is where our ASR comes in. So this is where your audio gets converted into actionable text with crucial timing information. Purpose: convert spoken words into text and provide precise start/end times for each word or segment. Okay, input, extracted audio file, models, libraries. Okay, we can use Whisper, Wave to Vec 2. Those are two examples that have been given. Okay, so now I need to look for two examples. I feel like if I make a mind map here, that'll be helpful. So let's do, uh, let's CD into this, and then what's the exact thing here? HF transformers. I think it's, oh my God, can you, there. Wait, what's the, um, hold up. I'm a bit confused. I don't want to close either of these, because, oh, let's go back. Learning HF transformers. Okay. Learning HF transformers. Um, Actually, you know what? I should have made the auto clipper project. I could do that now. Make direct, actually, where should I do that? Because, wait, didn't I have, let me just open this up. Hold on. I thought I created an auto clipper project. Okay, maybe not. Okay. So, let's start with that, I guess. Auto clipper proj. Uh, Wait. Let's say auto clipper app. Okay, in here we'll create, should I create it like directly in here, or okay, let's say auto clipper app proj O1. That doesn't need to be like an O1 and an O2 and stuff. I do need to like initialize the repo. First I need to create the project, then I need to initialize the repo in here, and then I want to install stuff. So, yeah, we can, it can just be this, you know, this entire thing should actually be in a different location. I shouldn't be keeping it here. I should put it into an actual, like I have a directory where I keep these kinds of projects. Maybe we could go into that directory. For the time being, let's just keep it here because Yeah. For the time being, we'll keep it here because I don't want to go back there and there's a bit of um, an issue on my end. Can I transition? No, I don't think I can transition. Okay, that's fine. Uh, so what are we doing here? So we copy the file path. Hopefully this works out. Yeah, it does. Okay, great. So uv venv.env p, actually I think the p comes before, p 3.14 .env. Okay, source. I did not mean to do that. Just a second. Yeah, let's delete that and go back. What I meant to do was this. Better. So now we activate it with this bin activate. Then we do uv. That's interesting. Did I mean to do that? I don't think I meant to do that. Uh, this is so silly, but I'm just gonna, yeah. Rm rf dot env. Okay, let's remove this. Perfect. Now let's do that. Great. Awesome. Okay, uv pip install. I don't think I need to install transformers right now, but I guess I can. Uv pip install transformers. Is there anything else I needed to install? No, I don't think so. I think we're good. Okay, transformers is done installing. Now we need to create our mind map. Let's just say project mind map dot HMM. Okay, this is our mind map. So stage one or step one. Do I need to say step one? I don't think so. Our first thing is pre-processing, right? So pre-processing. Split. Okay, use ffmpeg. Split MP4 file into video, audio, and no, hold on. Into video and audio files. Keep original MP4 file as well. We now have 3 types of inputs: video, audio, and what do you call video with audio? And okay, let's say video audio. So that's our pre-processing stage. Great, awesome. Next, we want to run ASR, but like, what exactly are we doing with ASR? It says video pre-processing. No, that's still step one. Okay. Speech to text transcription. Okay. So, this would be generate. No, let's say full audio transcription. Use ASR to generate a transcript for the entire audio. Okay, that's done. What's the next stage after that? Oh, yes. Okay, so this is where we need to look for look for lightweight models to run ASR. Yeah, we'll add that to the list. Okay, so now we can worry about whether to use FFmpeg. I think for the time being I can just use FFmpeg by itself, because to be honest, I'm not really doing very complex things with it. Actually, there's a doubt that I need to clear. Hey, so I've seen you mention, I'm still in that conversation that I was having about whether to use a wrapper, a Python wrapper library, or use FFmpeg directly through subprocess.run. But yeah, okay. Hey, so I've seen you mention um, filter multiple times. I don't really understand what that means here. Okay. In the world of FFmpeg, a filter is is any operation that modifies the video or audio frames themselves. Okay, think of it this way. Stream copying is like moving a sealed box from one room to another. You don't know what's inside and you aren't changing it, you're just moving it. Filtering is opening the box, taking the item out, painting it with a different color or resizing it, and putting it back into a new box. Filter graph. FFmpeg uses what is called a filter graph. This is a pipeline where the raw data flows from the input through one or more filters and then out to the encoder. Common examples for an auto clipper: since you are building an automated tool, you might eventually need filters like scale, resize. Oh, I forgot about that. For the video, we need to scale down the frames because these frames are going to be what resolution do I stream at? I think I stream at 720p. So that's what, 1366 by 768 maybe? I think so. Maybe. I'm not sure. Hold on. I'm looking at my OBS right now. I don't think I see I don't think I see a resolution. Just a second. Yeah, no, I don't think I'm seeing any resolution here. But yeah, it's one of the two. It's one of the two. I don't think I'm streaming. Actually, no, hold on. I think I'm streaming lower. Yeah, I'm not streaming 720 because of my internet. I just remembered that. I'm not streaming 720. I'm streaming 480. I think so. Just a second. I think, oh wait, no, I am streaming 720. I thought I was streaming 480. That's interesting. Okay, that's cool. But there's okay, the video player does have, or it should have, some sort of stats. Maybe I can hold on. I'm gonna open up my stream elsewhere and check exactly what is. Okay, it says 720 source. Okay, so I'm assuming I am I am streaming at 720, or it's possible that I'm Wait, hold on. Always show events. Okay, let's take a look at advanced video stats. Render resolution is 1280 by 720. All right. Viewport resolution is 592 by 330. Maybe that's because I'm not watching in full screen. I'm not sure. Download bitrate is 1000. I think I had set it at that. Yeah. Okay. All right. Cool. Great. Awesome. So now that that's cleared up, we can come back here. Okay. Well, either way, we're going to need to, when it comes to video stuff, we're going to need to scale the thing down. I wonder if we can scale down audio, or if we even need to scale down audio quality, audio sample rate. I don't know if that's going to ruin the, yeah, I don't know, maybe I shouldn't do that. Okay, I can look into that. If it ends up being like a very heavy process, then I can look into it. Okay, so since you are building an automated tool, you might eventually need filters for things like scale, which is resizing a 4K VOD down to 1080p for a social media clip, draw text, automatically overlaying the streamer's name or a highlight label onto the video. That's actually okay. That's it's interesting that Gemini mentions this, because I was planning on looking into a way to create a sort of how do I say this? So like Twitch has this thing where like they have a clipping tool. In the clipping tool, they'll give you the option for both like web, as in the bigger version, the let's call it the landscape version, and the portrait version. The portrait version is meant for mobile devices. They're meant, it's for like specific aspect ratio. For that aspect ratio, you can do a bit of editing to select. You're given like two squares or two rectangles, and you can resize the rectangles in different ways to decide how much of the rectangle occupies, or to decide what is occupying the top half and the bottom half of the video. You can also scale that, like in the final thing. It's pretty interesting the way that you can set that editing up. But I was thinking of doing something along those lines, because this is another issue that I'm gonna have, is that the editing that I'm doing is, or the final result that's going to be produced, all of those clips are still going to be in um, what do you call it, in landscape mode. They're not going to be in portrait mode. So if I am posting them, I'm going to have to do some sort of editing before posting them, or I just have to edit. I just have to post them as landscape clips, which I don't know if I want to do that. I kind of want to experiment with both of these methods. I want to see which one works out the best, because it is possible for me to do there's also the fact that whatever you're seeing on my screen right now, all of that is necessary. All of that is important information. Uh, None of that can be omitted, if that makes sense. Like at any given time, I usually do need the, well, I don't know how true that is. Well, okay, a good example right now is like, okay, I might not be using the browser at this very moment, the browser that's being shown on stream, but I will need it eventually, and usually I do need it. It's just that today I'm having a bit of a UI issue, so that's why I can't. I don't know if I'm going to be touching it all that much. But if you look at the bottom left and bottom right of the screen, the two separate screens that are being shown there, both of those are necessary. Both of those are important. One of them is a Gemini conversation. The other is this where I'm doing the actual like development. Um, so you have like these different windows that are showing up here. So at any given time, like I can't pick like a fixed layout that's gonna be, always um a one size fits all layout. I can't pick a one size fits all layout. What I can do though is I don't mind doing the bit of like manual editing if need be. I can probably pop the thing into the Instagram Edits app and do whatever editing that application allows me to do. That's a possibility. Yeah, okay. Anyways, full audio transcription. Okay, that's done. Wait, no, I was reading this. So draw text, crop, uh, turning a horizontal. Yeah, there it is. Turning a horizontal 16 by 9 video to into a 9 by 16 clip for TikTok slash shorts. Then volume. If your AI detects the clip is too quiet, you can boost the decibels. Okay, true. The trade off filtering versus copying. This is the most. This is the most important part. You cannot use filters and copy at the same time. With copy, it'll be blazing fast, limited only by disk speed, and it'll be slower with filtering, or the speed will be slower with filtering because it requires CPU slash GPU power. The quality, um, there's no quality settings because you're just doing cut and paste with stream copy, and with filtering, it's apparently infinite because you can change anything. What this looks like in code, a simple filter to resize a video looks like this in a command, ffmpeg so and so so and so so and so. All right, okay. All right, hold on. Would any of this be made easier if I were using something like PyAV? Because I remember PyAV did mention um, filters, or specifically the filter graph. So like they have implemented a way to do that through Python code. Okay, that's a great question. PyAV and FFmpeg via subprocess are fundamentally different ways of interacting with video data. FFmpeg subprocess is like hiring a professional. Okay, fine. PyAV is like having the entire toolbox and the raw materials in your hands. It provides Pythonic bindings to the FFmpeg libraries, allowing you to manipulate individual frames as data. Okay, here is how they compare for your specific AutoClipper project. When PyAV is better. If your project needs to look at the video frames to make decisions, PyAV is much better. AI analysis, if you want to feed frames directly from the video into your Hugging Face transformers without saving them to disk first, then PyAV allows you to decode a frame and turn it into a NumPy array or a PIL image instantly. Okay, custom overlays. If you want to draw complex dynamic graphics on every frame using Python logic, like a custom scoreboard or heat maps, then yeah, okay, you can use PyAV. All right. When subprocess FFmpeg is better. If your project is mostly about file management and processing, then subprocess is superior. Okay. Slicing with C copy. This is the big one. FFmpeg is highly optimized for stream copying. Doing a bit perfect stream copy in PyAV is significantly more complex to code and prone to errors like losing audio sync. That would be bad. Okay, hold on. That changes things. Simplicity. Writing one line of FFmpeg command is much easier than writing um, the 20 to 30 lines of PyAV code required to open a container, find the right stream, remux packets, and close the container correctly. You know what? That's fair. That is fair. Okay, all right. So for now, I guess we can use, because we are just doing simple stuff, we're not doing very complex things, we can just use FFmpeg, and I'll feed in, all the necessary input via the arguments list, the commands list, and whatever. Okay, there was one more thing I was gonna ask here. Okay, I'm opening up a new conversation for this. Actually, no, I can go and look at the HF transformers page. Okay, I'm looking for uh no, hold on. I'm working on, actually, okay. In this list, there are two things mentioned: Whisper and Wave to Vec 2. Whisper is apparently highly recommended because it's robust. It's a robust multilingual model that excels at generating accurate transcripts with detailed timestamps. Wave to Vec slash Hubert, other excellent options, though Whisper might be easier to get started with for an end-to-end transcription and timestamping. How it works: the model listens to the audio and not only predicts the sequence of words, but also records when each word or phrase was uttered. Output, a structured output, often JSON, or a list of dictionaries containing so and so. Okay. Right. So I need to, what would I be looking for specifically? Because like there would be different types of speech to text models, right? Okay, I'm working on an auto clipper for my to generate clips out of my Twitch VODs. I mostly do co-working and studying streams where I'm often doing some sort of coding. Um, I need to generate a transcript out of the audio of my VOD. Which models would you... Oh, I didn't mention... Okay. I'm using HF transformers, which models would you recommend using? Keep in mind, I'm running this on a mid-range, possibly even low-end system. For transcribing coding streams on a mid-range or low-end system, you need a model that balances memory efficiency, VRAM usage, with technical accuracy, handling jargon like camel case, async await, or specific library names. Since you are using since you are using Hugging Face transformers, here are the top recommendations for 2026, ranked by their suitability for limited hardware. So we have Distill Large V3. Okay, let's go take a look at that. I don't think I can do that locally right now, or rather on this machine where I'm streaming from, because I'm still having that little AI issue, UI issue. I'm still having that UI issue. Um, so I'm just gonna look this up on my other machine and tell you guys what I'm looking at. Distill Large V3, and this is from Distill Whisper. Okay. Distill Whisper was proposed in the paper Robust Knowledge Distillation via Large-Scale Pseudo-Labeling. This is the third and final installment of the Distill Whisper English series. The knowledge. It's okay, it's the knowledge distilled version of OpenAI's Whisper Large V3. The latest and most performant Whisper model to date. Compared to previous Distill Whisper models, the distillation procedure for Distill Large V3 has been okay. Are they like, where do they mention what exactly this was distilled on? Like what are, I don't know, like does that even make a difference? What specific type of knowledge? It should, right? It should make a bit of a difference. Okay, the result is a distilled model that performs to within 1% WER of large V3 on long form audio using both the sequential and chunked versions, and outperforms Distill Large V2 by 4.8% using the sequential algorithm. The model is also faster than previous Distill Whisper models, 6.3x faster than Large V3 and 1.1x faster than Distill Large V2. Sorry, zoned out. Okay. Since the sequential algorithm is the de facto transcription algorithm across the most popular Whisper libraries. This distilled model is designed to be compatible with these libraries. You can expect significant so and so, so and so. Okay, sequential long form, chunk long form, speculative decoding, additional speed and memory improvements. Also, there's short form transcription. Okay, library words, library integrations. Let's hold on. I'm curious about. Okay, this is supported by transformers. Distill large v3. Okay, I can use pipelines directly to get this. Okay, awesome. So hold on. This model can be used with the pipeline class to transcribe short form audio files less than 30 seconds as follows. Okay. Sorry, zoned out. Sequential long form. Unlike previous Distill Whisper releases, this one is designed to be compatible with OpenAI's sequential long form transcription algorithm. This algorithm uses a sliding window for buffered inference of long audio files greater than 30 seconds and returns more accurate transcription. I didn't take something into account here. I don't know. Okay, hold on. Wait, I need to come back here and right. So the top recommendation was Distill Whisper. That's fine. It says the VRAM usage is 5 GB. There is no revamp. No VRAM. There is no VRAM on the machine that. Well, I mean there is maybe actually no. The specific machine that I'm planning on using it on, there's no VRAM. Okay, best for low end systems is Whisper Tiny or Base. If your system has less than 4 GB of VRAM, or you are transcribing on a CPU, these are your best bets. Whisper Tiny, Whisper Base, and there's a note as well. Use the .en versions. If your streams are exclusively in English, they are more accurate and efficient than the multilingual versions. Oh, hold on. This is interesting. NVIDIA released something called Parakeet. Okay, Parakeet TDT, token and duration transducer. It uses a token and duration transducer architecture, which is much faster than the standard transformer encoder decoder used by Whisper. This is a 1.1 billion parameter model. Parakeet is real-time long VODs. Okay, you know what? We can take a look at it. Let's open up. So this is definitely not what I'm looking for. Distill large, because it requires VRAM. I don't know if it even works on the CPU. Maybe there is like some version that works on the CPU. But yeah, let's look up Parakeet. So there's NVIDIA Parakeet TDT 0.6 billion. There's Multitalker Parakeet Streaming 0.6 billion. Parakeet TDT 0.6 billion V2. Somebody made an Onyx version of it as well. I'll go for the Hold on, they have a 0.6 billion thing and they also have a 120 million thing. Let's see if they've listed any of the others. Yeah, they have V3 and V2. I'm looking at V. Okay, so there's multiple languages supported here, right? What if I go for specifically the English version as recommended? Hold on. Okay. Use case. This model serves developers, researchers, academics, and industries building applications that require speech-to-text capabilities, including but not limited to conversational AI, voice assistants, transcription services, subtitle generation, and voice analytics platforms. Okay. Okay. Really odd time for my mouse to die. Give me a second. Okay. So we are going to be, yeah. All right. Architecture type, fast conformer TDT. Input, 16 kilohertz audio, input format wave, and FLAC. Oh, I might need to resample the audio. I'm gonna have to see. I'm gonna have to see what the situation is there. Um, Output. The output is text format. The output type is text. Output format is string. Output parameters 1D, which is text. Um, Output parameters related to output. Okay, punctuations and wait, it doesn't mention that it's giving timestamps as well. Okay, the model achieves faster training and inference times compared to CPU-only solutions. That's great, but can I run this uh, on the CPU only? Would that work out well, or um, transcribing with timestamps to transcribe words to transcribe with timestamps? Holy shit! Let's take a look at okay. ASR model dot transcribe timestamps equals true. Oh, okay. All right. Transcribing long form audio. What is the limit for this? Yeah, because I didn't take that into account like at all. That this would need to be divided up into because I don't think the entire 2.5 hours, like let's go for the high end, 2.5 hours, because my streams are usually anywhere between 1.5 to 2.5 hours. I don't think the entire 2.5 hours of my stream is required, as in, for the, I don't think the entire 2.5 hours is relevant to the, the 3 minutes of the clip. That's what I'm trying to say. So how do I want to go about this? Okay, let me have this conversation. Hold on. Okay, so here's my issue. I'm doing CPU only inference, at least for now. And let's say I'm limited to 4 to 6 GB of RAM. If a VOD is around 2.5 hours, how would I go about using one of these models? Is 2.5 hours way too much to feed in at once? A 2.5-hour VOD is far too large to feed into a model as a single raw tensor, especially on a system with 4 to 6 GB of RAM. If you tried to load an entire audio file into memory, you would likely run into an out of memory error before the model even starts processing. Okay. For CPU-only inference on long files, you should use chunking. How chunking works. Instead of transcribing 2.5 hours at once, you break the audio into small manageable slices, usually 30 seconds each. That's crazy. Okay, HF pipeline solution. The Hugging Face pipeline has built-in support for this. You don't need to manually cut the file with... Okay, that's good to know. That is good to know. You don't need to manually cut the file with FFmpeg. You just set the chunk lengths parameter, memory efficiency. When chunking is enabled, the system only keeps the current chunk and a tiny bit of overlap in active memory, allowing you to process a file of any length, even 10 hours, using the same 4 GB of RAM. All right. Recommended model, distillsmall.en. Since you are on CPU only with 4 to 6 GB of RAM, Distill Large might still be sluggish or push your RAM to the limit. Distill Small is the sweet spot for you. It is incredibly lightweight, very fast on CPUs, and much more accurate than the standard base model for technical coding terms. RAM footprint, roughly 1 to 2 GB during active inference. Implementation. Okay, pipeline, automatic speech record. You know what? Okay, another thing I could do is, okay, so now we are looking at Distill Small. Distillsmall.en. Great. So this is made by Distill Whisper. It's a 0.2 billion parameter model. Distill Whisper was proposed in the... Okay, this is... Yeah, fine. This is the... This is the repo for Distill Small EN, a distilled variant of Whisper Small EN. It is the smallest... Oh, wait, I just realized I'm reading this as 0.2 billion. So that's 200 million, basically. Yeah, 200 million. It is the smallest Distill Whisper checkpoint with just 166 million parameters, making it the ideal choice for memory constrained applications, example on device. For most other applications, the Distill Medium or Distill Large checkpoints are recommended since they are both faster and achieve better WER results. What is WER here? This is some kind of benchmarking term. Benchmark WER. Is it benchmarking or evaluation? Okay, benchmark WER refers to word error rate, a key metric to compare and evaluate the performance of different speech-to-text ASR systems. With lower WER indicating better accuracy, scores below 5% are excellent. 5 to 10% is very good. 10 to 20% is good for clean audio, and above 20 to 30% is generally poor, with benchmarks often comparing models on datasets with real-world challenges like noise and accents to define leaders like NVIDIA's Parakeet or IBM's Granite. Granite? Granite. Okay. All right. So this is a benchmarking thing. All right. Cool. So how would I know? Okay. Wait. I just realized that I'm doing a whole bunch of stuff off screen right now. I'm not really doing anything on screen. I'm mainly just saying what I see. Okay, this is great. Also, 30 sec is too low. I was hoping to be able to feed in at least 10 minutes worth of um, audio in there. Yeah, okay. At least 10 minutes worth of audio in there. Also, uh, these are great suggestions. I'm wondering, how would I go about doing these kinds of searches myself um, on the HF Model Hub? Because I feel like this specific kind of thing can be a little complicated to find. Okay, I understand the instinct to want larger chunks. 30 seconds feels like baby steps. When you have backup, hold on, I just realized something. When you have 150, okay, so I'm going to read this, but after that I'll tell you what my idea was. Actually, let me tell you what my idea was. Okay, if we are only able to generate, let's say, 3 minutes worth of transcripts at a time, why not run the model multiple times and just stitch all of the transcripts together? I feel like that would work out, right? Though I think there would also be cutting in between with the transcripts. Because, like, let's say the transcription, let's say we have 6 minutes worth of footage. Okay, we split it up into 3 minutes and 3 minutes. Right at the 3 minute mark, I'm saying something. I'm in the middle of a sentence, right? Or I'm in the middle of a word and the audio just cuts out right there, right? But then that continues in the next audio clip. Now, that one word or that maybe series of words is not going to be transcribed properly. I mean, if it's a series of words, maybe it'll be transcribed properly. If it's one word, maybe it might just get broken up because it's not going to make sense, right? Half audio here, half audio there. That being said, this is still a transcript. I need to keep that in mind. This is still a transcript. It's not the original. Like, we're not gonna that's not gonna be the final result. So in the final result, we're not gonna be cutting out audio. I mean, we kind of are, but like it's not gonna be as bad as like what I'm imagining here. Okay, keeping that in mind, if I'm able to, so 2.5 hours is out of the question, right? Even 2 hours, even 1 hour, out of the question. If we are able to divide this into smaller chunks, we could just rerun the process over and over again. Now, okay, Gemini has mentioned something here. Okay, so it said, I understand the instinct to want larger chunks. 30 seconds feels like baby steps when you have 150 minutes of audio to get through. However, there's a technical reason why nearly all whisper-based models use that specific window. Why 30 seconds is the hard limit. Most state-of-the-art speech models, especially Whisper, use especially Whisper, were trained on 30-second clips. Their entire attention span, quote unquote, that is the positional embeddings, is hard coded to that length. If you feed 10 minutes at once, the model won't just be slow, it will likely fail to produce a coherent transcript or throw a shape mismatch error because it doesn't know how to map audio features beyond the 30-second mark. Chunking, the illusion. When you use chunk length 30 in a Hugging Face pipeline, it feels like the model is transcribing the whole 10 minutes. Behind the scenes, the pipeline is cutting. Oh, I was thinking that I might need to do that, but no, it turns out Pipelines is handling that for me. Okay, behind the scenes, the pipeline is cutting the audio into 30-second slices, processing them one by one, and stitching the text back. It's doing exactly what I was planning to do. Okay, great, awesome. That saves me like a ton of time. Behind the scenes, the pipeline is cutting the audio into 30-second slices, processing them one by one, and stitching the text back together for you. This is the most memory efficient way to handle a 2.5-hour VOD on 4 to 6 GB of RAM. How to search the Hugging Face Hub like a pro. To find models that fit your specific hardware, CPU only, low RAM, and niche coding/technical, follow these steps on the Hugging Face Model Hub. Filter by task on the left side, okay, ASR. Sort by downloads/trending. This usually floats the most efficient community vetted models like Distill Whisper to the top. Okay, use the search bar with keywords. But the keywords here are Distill Whisper and Guff or Onyx or English. None of this is going to help me with what I'm trying to do. Check the model card, look for a VRAM or size table. Since you're on a CPU, look for models under 500 MB for tiny base or 1 GB for small/distill to ensure they leave enough RAM for your OS and other background tasks. Recommended advanced search strategy. Search for Whisper Base EN quantized. This will show you versions of the model that have been shrunk or quantized to use even less RAM while maintaining performance on CPUs. Okay, hold on. It's interesting that you mentioned the 30 sec limit thing, and I'm glad that you did because I had no idea that it was actually a technical limitation. I'm yet to learn how to build and train transformer models in PyTorch, and I'm also yet to go through the entire LLM course on HF to learn all about using transformers and using HF transformers and transformer based models. Okay. Right. That is exactly why the Hugging Face pipeline is so powerful. It abstracts away the ugly math of slicing audio and stitching it back together so you can focus on building your auto clipper. That's true, actually. I would have had to spend some time working on that logic. Maybe not too much time, but some amount of time. And now that amount of time gets saved because, well, what was I saying? Yeah, now that time will be saved and that headache will be saved, and I'll be able to focus on the more high level tasks that I'm trying to accomplish. Okay, it abstracts away the ugly math of slicing audio and stitching it back together so you can focus on building your auto clipper. When you eventually dive into the HF LLM course, you'll learn that this 30-second window is a result of positional encodings. In a transformer, the model doesn't inherently know the order of the data. It uses a map to understand where it is in time. For Whisper, that map was printed for 30-second segments. If you go to 31 seconds, the model will literally lose its place on the map. Pro tips for navigating the hub. Okay, all right. Hold on. So now we know that we need this small version. Am I looking at small? Oh, small was in this list. So I was looking for lists. I was looking for like a list of these the distill models. So like, distill large and then distill medium, and now there's distill small. Specifically distill small EN, which is 166 parameter, 166 million parameters. So it's going to be pretty lightweight. Probably still heavy for my system, but like, lightweight in a general sense. And also, there's also the fact that I am planning on running this on the cloud. So there is a little bit of, there's a there's a little bit of a cushion there in terms of resources. The problem is, like, I'm initially testing these models on my machine, so there has to be a certain amount of resources on my machine just so I can actually load the models, even if later on I end up using, I don't know, a heavier version or heavier settings, or okay, if it turns out to be simple enough to switch out, let's say, distill small with distill large once I get to the cloud, once I'm running it on the cloud, if it ends up being simple enough and the output remains the exact same, then I'll do that. I'll do exactly that. Okay, now, um, hold on. Okay, help me understand how I'm able to feed even 10 hours worth of footage, or audio, actually, this is not video. Even 10 hours of audio, but it still only consumes, I spelled that wrong, consumes 30 seconds worth of audio. How is that working exactly? And in terms of, hold on, how do I want to, what exactly am I trying to ask here? Oh yeah, in terms of processing multiple 30-second chunks, how is Pipelines doing that internally? Are there multiple processes being launched for it? Hold on, launched for it? Or is it just sequential? Sequential. There, okay. One after the other. And it'll take however long it takes and eventually give me the result. Okay, it feels like magic that a 2 GB model can digest a 10-hour file without exploding your RAM. The secret lies in a process called streaming and sliding windows. Since you are diving into the HF Transformers ecosystem, understanding this plumbing will help you debug why a script might be slow or why it's hitting a memory wall. How the 10-hour file fits. The pipeline does not load the 10 hours of audio into your RAM as one giant block. Instead, it uses a generator pattern. Step 1, loading. It opens the audio file using a library like librosa or ffmpeg. It only reads the first tiny bit of data. Step B, slicing. It cuts the data into a 30-second stride. Step C, feature extraction. It converts that 30 seconds of sound waves into a MEL spectrogram. I'm okay. Something I'm really curious about, which I'm not entirely sure if I should dive into right now, but like I'm still deciding on that. Sound waves into a MEL spectrogram, a mathematical image of the sound. Then step D, inference. It feeds only that spectrogram into the transformer. Step E, clearance. Once the text is generated, it tosses the spectrogram out of RAM and moves to the next 30 seconds. How pipelines handles the chunks. By default on your system, the pipeline is sequential, synchronous. It processes chunk 1, then chunk 2, then chunk 3. Are multiple processes launched? No. By default, Transformers runs on a single process. It does not automatically spawn new Python processes because moving large model weights between processes is very memory expensive. How it handles the seams, overlapping. If a model cuts a sentence exactly at the 30-second mark, the transcript would be cut in half. To fix this, pipeline uses an overlap stride. It might process 0 seconds to 30 seconds, then it processes 25 seconds to 55 seconds. Oh, that's interesting. It looks at the 5-second overlap, realizes the words are the same, and then stitches them together. Oh, there's a certain level of like, I'm not even sure what to call it. Like, would that count as NLP or audio processing or what? But there's a certain level of like, I think that comes under, I think that comes under NLP. Because like it does the overlap, right? And then where there's an overlap, it uses NLP to figure out like if there's like similarity there, and so it might be the exact same thing, and then it kind of stitches it properly. That's crazy, dude. This is what I was worried about, and this is being taken care of. The sequential reality. On a CPU only system with 4 to 6 GB of RAM, sequential is actually what you want. If you tried to process 4 chunks at the same time, parallelism, your CPU usage would hit 100% instantly. Your RAM usage would quadruple, 4 chunks multiplied by the model size. Your system would likely swap to the hard drive, making it 100 times slower, or just crash. The result, it'll take however long it takes. Okay. Usually on a decent CPU with just still small, it takes about 20 to 30 minutes to transcribe a 2.5 hour VOD. Okay, cool. Relevant HF course chapters. Tokenizers, audio course, slicing and truncating, building. Okay. Holy shit, dude. Yo, this is crazy. Yeah, no, this is crazy. Okay, I'm glad you mentioned the overlapping thing, because that's actually something I was concerned about. I'm wondering how that's being handled. Is that using some NLP techniques to figure out if there's similarity between those few seconds, or is there something else being used? Also, I'm confused about how it's able to read how, let me mention what it is, how pipeline is able to read um, only, how do I say it? Only a specific few seconds anywhere in the audio. Because I remember reading up on video encoding, and my understanding was that because of the way some of these encoding algorithms work, just removing some frames could actually break the algorithm, because some of them are basically how do I explain this? Some of them are more or less recording changes between frames rather than the entire frame. I'm wondering if it's something similar with audio, and if it is, I'm confused about how Pipelines is able to just take out a couple seconds of the 10-hour audio without having to first load the entire thing. Okay. This is a fantastic technical question. You've hit on the core difference between temporal compression, uh, which is for video, and random access, which is audio/file seeking. Your intuition about video encoding is 100% correct, but audio and the way Hugging Face handles it works quite differently to ensure you don't have to load 50 GB of RAM, 50 GB into your RAM just to hear the last 30 seconds. The video versus audio seeking mystery. In video, you have iframes, full pictures, and PB frames. Only the changes. To see a frame at 1 hour, 5 seconds, the player often has to go back to the nearest iframe at 1 hour exactly and calculate all the changes forward to that 5-second mark. Audio handles this differently. Uncompressed. These are like a long strip of paper. To get to the 10-second mark, the computer simply calculates byte rate multiplied by 600 seconds. It jumps exactly to that byte and starts reading. No previous context is needed to understand a sound wave. And it's compressed. These use frames, but they are much similar, much smaller. They're much smaller, as in milliseconds. Even if there's a dependency, the header of that file, which is the metadata, provides a map that tells the computer exactly which byte corresponds to which timestamp. How HF Pipeline does it? It uses a library called FFmpeg or dchord in the background. These tools are designed to jump to a timestamp without reading everything before it. It basically says to the OS, give me the data starting at byte X and ending at byte Y. How the overlap is handled, the NLP magic. When you set a stride or overlap in Hugging, oh, I have to set the stride for to allow for an overlap. Okay, I need to keep that in mind. The model transcribes the overlapping part twice Imagine you have a sentence, I love coding in Python because it is easy. Chunk 1, 0 to 30 seconds, ends with I love coding in. Chunk 2, 25 to 55 seconds, starts with coding in Python because. The pipeline logic, it transcribes both the chunks fully, it looks at the timestamps and the text tokens. It uses an algorithm, often longest common subsequence or a specialized stitcher to find where the text overlaps. It clips the redundant text from the end of a chunk, from the end of chunk 1 and the start of chunk 2 and joins them. Probability scores. If chunk 1 says coding in with 90% confidence and chunk 2 says, oh wait, is it also like maybe looking at the tokens themselves, not just the actual like text? Because they're mentioning probability scores here. Okay, anyways, with confidence, with 90% confidence, and chunk 2 says coding in with 99% confidence, it will favor the version from the chunk where the audio was clearest, usually the one where the words weren't cut off at the very edge. The technical flow, the plumbing. When you run pipe long VOD, here's the internal sequence. The streamer, an audio loader like FFmpeg opens the file, it doesn't load it, it just holds a pointer to the start. The chunker, that's an interesting name. The chunker, it grabs 30 seconds of raw bytes, converts them to a MEL spectrogram, that is the image the model actually reads, and then sends it to the CPU. The CPU processes that image and turns it into text, then memory release. As soon as the text is generated, the 30-second image is deleted from RAM, and then the pointer move. The audio loader moves its pointer 25 seconds for... Dude, okay. What's being done by pipeline here is definitely much more sophisticated and much more efficient than what I was going to do. I feel like my thing was still going to have some holes in the logic and some little kinks to work out here and there. But eventually I probably would have gotten to this point, where pipeline is right now. But that would have still taken me some time. I would have had to figure out, the logic issues. Holy shit, I'm glad that I'm having a conversation with Gemini about this, dude. Holy shit. This is saving me so much time. Anyways, the pointer move. The audio loader moves its pointer 25 seconds forward, leaving a 5-second overlap, and repeats. Summary for your auto clipper. Because of this pointer system, your 6 GB of RAM is safe. The RAM usage stays flat, whether the VOD is 5 minutes or 5 hours long. The only thing that grows is the size of the final text string that in your Python variable. Okay, so using this method, dude, I'm so glad that I'm having a conversation with Gemini about this. Like, holy shit, there's a bunch of things that I just wouldn't have known if I wasn't talking to Gemini about this. I need to do this. I need to stick to doing this rather than, still doing, my own searches and my own, Googling here and there. It does help, but there's so much extra information that I'm getting, helpful, not just, useless, helpful extra information that I'm getting that I would have otherwise had to spend a little bit of time digging up myself, because I'm sure other people have run into this issue and they must have asked questions on like the Hugging Face, whatever the Hugging Face forum is. I think it's called discourse.huggingface or discuss.huggingface or something like that. Hugging Face has their own like forum where you can ask questions and stuff. I would have probably landed on one of the threads there, and I would have gotten the information from that. But hold on, give me a second. But man, I forgot to breathe, and then I suddenly had to breathe, and then I just like forgot what I was saying. I would have probably had to spend some time doing some searches that would eventually lead me to the Hugging Face um, forum. But the thing is, I would have had to spend that time doing, some sort of search when I could have instead just had a conversation with Gemini about it real quick and saved some time. Okay, so I can basically feed a 2.5 hour VOD into a pipeline. Would I be doing that? I don't. Yeah, I think I would into pipeline, and uh, as long as I mention the chunking related um, variables, arguments, uh, it'll handle all. It'll handle all of that splitting. Well, chunking essentially, all of that chunking and processing of small chunks for me. And then finally, give me the entire 2.5 hour VOD worth of transcript in one go. Because this, dude, like, this massively helps. This massively helps. Because initially, I was concerned that, oh, this one small step itself is going to be a bit of a chore because there's a bunch of things to handle here. But it turns out I don't need to do that. I feel like because like I'm okay, I'm proud of myself for coming up with this idea. Immediately, I was like, okay, I don't know if it was immediate. I think it was immediate. I think like as soon as I saw that I had this problem, immediately I got the idea that okay, maybe I can solve it in this way. Let's chop it up into smaller pieces and then feed those pieces in one by one, and then we can stitch things up together later on. My version of stitching wasn't going to contain this overlap thing. I did not, I don't have the technical know-how of NLP related stuff at all to be able to achieve that, at least right now. So I wouldn't have been able to achieve that. Um, what I would have gotten is, what I would have done is just processed 30-second chunks and then stitched them all together. And anything that gets broken up in between the splits, it just stays broken. I was gonna I was gonna hope that the any of the further models that are going to be using these transcripts or this one transcript or like chunks of transcripts, they would be you know um, they would somehow guess whatever the broken word was or the broken sequence of words was, and they would guess the sentence or whatever. But yeah, I'm glad that I figured this out myself. In the future, though, I definitely need to make it a habit to ask Gemini that, hey, see, this is the thing that I'm doing. I've run into so and so problem. I do have an idea for doing so and so thing, but is there an easier way to solve this problem? Because I've run into way too many situations now where it's like, okay, yes, there was an easier way. I just needed to search for that easier way, and I would have been able to save myself a bunch of headache, but I decided to give myself a bunch of headache. All right. So Gemini replied, yes, that's exactly right. If you feed the 2.5 hour file path into the pipeline and set chunk length uh, equals 30, HF handles the heavy lifting of slicing, processing, and stitching. When the script finishes, it runs one large dictionary. It returns one large dictionary containing text, which is the full stitched together transcript, the full stitched together transcript string for the entire 2.5 hours, and then chunks, a list of individual segments. So that's how it does the chunking. I was, okay, right, hold on. There's something else that I was confused about. Let me show you, since we do have an example here. This right here. I was confused about how exactly it is handling, like how is it deciding how many words should go into a certain time frame? Like, is it deciding, you know, X number of words will be recorded into one chunk, or is it listing out all the words that were within a fixed slice of time, meaning it only follows that slice of time. So let's say 30-second intervals or 15-second intervals. So it's always like 15-second chunks. Even if there's a bit of an overlap, that's fine. Like in this case, it's handling it for me. But yeah, is it following? And yeah, this kind of answers my question that, okay, it's 30-second chunks. So actually, no, hold on. So this is saying that, wait just a second. So this is mentioning that it's going to return the entire text, and then it's also going to return chunks, a list of individual segments with their specific start and end timestamps, perfect for your auto clipper. You know what? That's true. Yeah. This is great for the auto clipper. Oh yeah. Now after that will come the next stage, right? Okay, so now we've actually, okay, I think I need to update the mind map here. Full audio transcription, use ASR to generate transcript, look for lightweight models to run. 30 sec is the limit for chunks. So use chunking, or actually not chunks. 30-second is the limit for clips that the model takes, that the model processes. So use chunking to be able to feed 2.5 hours worth of audio into the model, and pipeline will handle the chunking and stitching. Pipeline also, no, during the stitching, pipeline also handles broken words using stride to create an overlap between chunks. Okay. All right. So 30 seconds is the limit for clips that the model processes. So use chunking to be able to feed 2.5 hours worth of audio into the model. The pipeline will handle the chunking and stitching. During the stitching, pipeline also handles broken words using stride to create. Oh yeah, where do I mention the stride? Okay, by default it overlaps 30-second windows. it overlaps the 30-second windows. Example, it might look at 0 to 30 seconds and then 25 to 55 seconds. So there's a 5 second overlap there. Okay, all right. Important CPU/RAM considerations. Since you're on a 4 to 6 GB RAM system, there are two behaviors to keep in mind. The one-go memory peak. While the processing is memory efficient, the pipeline typically stores all the transcribed chunks in memory until the very end to give you the final all-in-one result. For a 2.5-hour VOD, the text itself is tiny, but the list of timestamps can grow. Your 6 GB RAM should be more than enough for this, but don't be surprised if the Python process stays active for a long time without printing anything. Okay, yeah, true, true. Then batch size. On your CPU, keep batch size equals 1. If you set it higher, wait just a second. Okay, if you set it higher, the pipeline will try to load multiple 30-second spectrograms into your RAM, which would lead to a crash. A better way for long VODs, the generator, instead of waiting 30 plus minutes for the one go result and praying it doesn't crash at the 99% mark, you can turn the pipeline into a generator. This lets you process the VOD chunk by chunk and save the text to a file as it happens. Okay. Batch size 1, timestamps, okay. All right. Wait, no, hold on. I don't get it. Wait, so, okay. Okay, so a couple of things. This example that you gave, does it still maintain the stitching logic that prevents broken words and sentences? You mentioned stride and that the default stride is 5 seconds. Can I control the stride? Or is there usually no need to do that? Okay, great technical instincts. Let's break. That's crazy. All right. Let's break down exactly how the generator style affects the output and how you can tune that seam between chunks. Does the generator maintain the stitching logic? Yes, but with a slight catch. Sorry, zoned out. Okay. Um, does the generator maintain the stitching logic? Yes, but with a slight catch. When you use the pipeline as a generator, the for chunk in pipe syntax, Hugging Face is still running the stride slash overlap logic internally. It transcribes the 5-second overlap and uses it to ensure that the words aren't cut in half. However, there is a subtle difference in how the text is delivered to you. In the one and go method, no, in the one go method, the pipeline waits until the very end, looks at the entire 2.5 hours, and performs a final pass to make sure the punctuation and capitalization flow perfectly between segments. The generator method, it gives you the best guess for what it gives you the best guess for that 30-second window immediately. Because it hasn't seen the next chunk yet, the very last word of the very last word of a chunk might occasionally lack the perfect context of the following sentence, but the word itself will not be broken. For an auto clipper, the generator is superior because if your computer restarts at the 2-hour mark, you have lost the first 2 hours of work. Controlling the stride. Yes, you can absolutely control the stride in the Hugging Face pipeline. This is handled by the stride length parameter. Should you change it? Usually the default 5 seconds is the sweet spot. Here's why you might change it. Increase stride. If you speak very quickly or use extremely long technical terms, that might get cut off. Okay. This gives the stitcher more data to find a match, but it makes the transcription slightly slower because you are reprocessing more audio. Decrease slide, decrease stride. If you are on an extremely low end system and need to squeeze out every bit of speed, then do this. However, this increases the risk of hallucinations or doubled words at the seams. Okay, I don't need to change it right now. I don't have a good reason to change it. All right, great. So we have something to work on here. We have um, oh, look for lightweight models to run ASR. What did I find here? I found distill small.en. All right, great. So this should give us the entire, so result, full transcript of entire audio containing full text along with chunks of text and their timestamps. I might need to change this later once I actually have a look at the result. But yeah, I now have this one thing to look at and actually test out. And I'm gonna do that. I need to find a quicker way to like record audio, or maybe I can just. Oh, I don't need to. No, I don't need to do that. I can just split up my own VOD and then, well, split the video and the audio in my own VOD and then pass in. I just noticed it mentioned in the example MP4. Are we passing in a video or an audio? I need to see what the model accepts. But anyways, um, yeah, I have my own VOD, so I can. I'll just need to write some. Actually, I don't even need to write some code for that. I need to talk to Gemini about the commands to first of all, split the audio and the video into two separate things, and then use only the audio and slice out like 30-second segments out of the audio. Oh, actually, no, not slice out 30-second segments, 5-minute segments. So that way I can feed 5 minutes or 10 minutes worth of footage into the model and see what the transcript looks like. That should be interesting. And usually the first like couple minutes of my stream, I'm like yapping a lot. So much so that sometimes I just go off track from what I was originally supposed to be doing on the stream. So I think the first like 5 to 10 minutes, in fact, even the first 30 minutes, I've done that where I've just been talking and talking and talking. And like I look at the time, the elapsed time, and it's like 20 minutes have passed or 30 minutes have passed. And then I'm like, okay, shit, we've just been yapping for 30 minutes and we haven't really gotten into what we were supposed to be doing. Also, massive bonus that the streams are in English, so I only have to use the English model, and that is much smaller and hopefully much more lightweight. But yeah, dude, we've made some good progress here. This is our transcription, full audio transcription step, right? After that, so we produce the timestamps. Great. Addressing the big blob concerns. Right. As you can see, this output is not a single blob. It's a sequence of short text segments, each precisely time aligned to the original audio. This is the key to linking text analysis back to specific video moments. Contribution, it provides the textual content for NLP and a foundational timeline for all other analyses. Then NLP for textual insight. So this is where I feel like I might be using multiple models to get different types of information. Yeah, yeah. Now that you have transcribed text with timestamps, you can analyze its meaning and sentiment. Um, I forgot what I was gonna be doing. I'm looking at this right now, so I'm gonna. Oh, okay, yeah. I was saying, I'm gonna need to use multiple models for various purposes here, like to do different types of analyses on the transcripts. I have to first try and find out what exactly I'm looking for. I also need to see if, okay, so we have sentiment analysis here. We have named entity recognition or keyword extraction. So I can do like custom NLP here using these various tools that are available, tools and probably models as well. I feel like that would be, I feel like that would be a bit more like beneficial. It would give me a little more control over like what exactly is what am I trying to control here? Well, no, it gives a little more granularity. Like I can then I can then determine that okay, this is these are the topics that are being talked about in this clip. And so based on that, I can do something, right? Now, the question is, a bunch of these techniques that are being suggested here, just some of them that have been suggested are sentiment analysis and named entity recognition. Fine. Um, the question is, wouldn't wouldn't these be possible using an LLM? Like I could just give the LLM a prompt and say, hey, do this on this, like I can give it a proper prompt to give me exactly the kind of information that I'm looking for. That's a possibility. Though, yeah, I'm not sure. Okay, I guess okay, hold on. So the purpose apparently for this step is to extract meaning, sentiment, and key information from the transcribed speech. Oh, you know what? I could use these smaller models to get these bits of information and then feed that entire chunk of video or that entire chunk of audio into um what was I saying? Yeah, feed that entire chunk of audio or that entire chunk of transcript, in fact, into um into an LLM rather than one of the, NLP models. I could feed it into an LLM along with the results of these other NLP models. Because these NLP models would then tell me about, the mood of the clip, the topics being discussed in the clip, and various other bits of information, things that were mentioned in the clip, right? I can feed all of that into the LLM. But then wouldn't the LLM be able to do all of that anyways? Okay, I need to do this in practice and see exactly what I'm trying to do, because I feel like one thing that's making me kind of unsure of what method to use is that I'm unsure of what exactly I'm trying to do in the first place. So I need to actually do it. And then later on, I can decide if I want to use an LLM to perform these tasks. Moreover, I'd imagine using these models individually would be much, much less performance heavy than using an entire language model. So like I could use more heavier versions of these NLP models for various purposes. Actually, okay, these aren't just, should I be calling them NLP models or language models? I think they classify as language models, right? Because I'm seeing BERT being mentioned here as well. I need to do some research on like the terminology here. Um, what was I saying? I forgot what I was saying. Yeah, okay. Anyways, let's yeah, I need to do research on like the terminology surrounding this. But my point is, I can start by using these models that are being suggested. Also, I could try using these statistical methods because this is also being suggested. Though I feel like I might have a better time with the models themselves rather than the statistical methods. And especially because it's mentioned here, Hugging Face models fine-tuned for named entity recognition. So I feel like that would give me better results. Okay, how it works? You'll iterate through your time-stamped segments, perhaps grouping them into 5 to 10 second chunks. Yep, I was planning on doing that, and run each chunk through your chosen NLP models. Output: for each text segment, you'll get sentiment scores, extracted keywords, identified entities, and this output is also time aligned because it corresponds to the input segments, the input segments timestamps. Contribution: this identifies spoken moments of excitement, humor, frustration, key information, or important topics. Okay. Then, audio event detection for non-speech cues. Beyond just speech, the sounds in your VOD can be powerful indicators. I feel like I can skip this. I feel like I might be able to skip this because my VODs, at least the ones that I'm processing right now, they are mainly VODs where I'm talking. So the majority of what I'm trying to process is speech. And usually if there is any sort of audio, I'm usually like splitting that and removing it from the VOD. So let me read through this entirely and see if I'm able to use this step at all. If I'm not able to, then I'll just, not bother with this. But if I am able to get something interesting out of it, then I could. Because, okay, it mentioned funny here, so laughter. That's not necessarily speech, but like, if it's not being counted as speech, but it's being counted here, we could extract the very few rare funny segments. Then it mentions memorable cheers, specific game sounds. That's not going to happen. Exciting, sudden, loud noises, moments of speech alone might miss. You know what? Okay, that's fair. No, that's fair. That's fair. I can do the exact same thing here as well. I'll have to see how to go about doing the chunking thing in this case. Because does this count as ASR? No. This is audio event detection. Okay, all right. We can look into this as well. Step 5, computer vision. This is where it becomes a little heavier. The visual content of your stream can provide context and highlight triggers. Analyze video frames for visual information that indicates interesting moments. Input: either the original VOD file analyzing frames directly or the extracted image frames from step 1. Okay. Right. Object detection, action recognition, facial emotion recognition if you have a face cam. All right, what's the next thing? We'll get to this part. Later on, because I feel like initially we're going to be able to produce quite a few clips using only audio, because there's quite in my streams it's mostly talking. Well, talking and doing, the stuff that I'm doing, but talking, a lot of talking. And there's no face cam here. It's my VTuber model. But there is a lot of talking. So like from the first few steps, we are going to be able to get quite a few interesting clips. Feature aggregation and fusion. This is where you bring all the information together. Combine the timestamped outputs from STT, NLP, AED, and CV into a unified representation for each small time window in your VOD. Input: all the timestamp data generated from steps 2 to 5. How it works: define a time window, choose a small consistent time interval, example 1 second, 5 seconds, 10 seconds, across the entire VOD. Align the data. For each time window, gather all the relevant data, such as the text transcript and its NLP features for that window, any detected audio events within that window, any detected visual events within that window. I feel like I'm going to need to keep the chunks. Okay, I was about to say that I feel like I'll need to keep the chunk length standard, but I don't think that's going to help here. Yeah, no, it's going to be a little more complicated than that. Okay, anyways, create a feature vector. For each time window, create a single feature vector that summarizes all this information. This vector might contain average sentiment score for the text, presence/absence of specific keywords. Apparently, that's called one-hot encoding. Count of laughter events, presence/absence of victory screen detection. Okay, in my case, that would be something else. Dominant facial emotion. All right. Output. A sequence of feature vectors, each representing a distinct time window of your VOD. A sequence of feature vectors, each representing a distinct time window of your VOD. Feature vector at so-and-so, feature vector at so-and-so. I'm going to need to look into this a little more to understand exactly what I'm supposed to be doing here. Contribution. It creates a comprehensive fingerprint for every moment in your VOD, making it ready for the final highlight prediction. Step 7, highlight prediction/classification, the Uber model or final classifier. This is the core of identifying interesting moments. Train a model to classify each time when, oh, that's why we are creating feature vectors. Okay. Train a model to classify each time window as interesting or not interesting. Input the sequence of feature vectors from step 6, your data/training. This is the most crucial part where your definition of interesting comes in. You will need to manually label segments of your past VODs. For example, watch a VOD. For every moment you consider oh God, okay. Mark its start time and categorize it. This labeled data, I'm sure I'll be able to find like some model that does like a generalized version of this. This labeled data will be your training set. Okay, models/libraries, simple neural networks, recurrent neural networks, support vector machines. All right. How it works. The model learns patterns in the aggregated features that correlate with manually labeled interesting moments. For each time window, a probability or a binary prediction, 0 or 1, indicating if it's an interesting moment. And okay. Contribution. The core logic for identifying the exact moments you want to clip. I'm gonna have to see what to do about this step. Then finally, we have post-processing and extraction. The final step converts predictions into actionable clips. Process, refine the predicted highlights, consolidate them, and prepare them for your clipping tool. Input, the timestamp is highlight predictions from step 7. Okay, filter and consolidate. You'll likely get many contiguous is highlight true predictions. You'll need logic to combine adjacent positive predictions into a single longer highlight. Set a minimum duration for a highlight, and for each identified highlight, you then apply your 60-second window logic. Okay. All right. This gives us the final list of clips that we can then slice. Oh, okay. All right. Now, give me a second here. Okay. You know what? Yeah, we're gonna go to this person's. Hold on. So there's a person called Free to Be Me. I hope they don't have their I hope they don't have like raid settings that prevent smaller raids or raids in general. Nah, we're good. Okay. All right, cool. So, that's gonna be it for today's stream. We've made some good progress. Like holy shit, we've made some good progress, and I'm happy about that. We have to go. We have to go step by step with this. Of course, we read through the entire thing here, which I don't think I've ever done ever since I had that conversation with Gemini. I don't think I've ever read this entire, step by step process that Gemini had prepared. But yeah, we've read through this, and now we can go through this entire thing one by one, and we don't have to strictly follow what is being said here. These are just like, pointers. So this gives us an idea of what we can do. And yeah, yeah. From the audio transcripts alone, I feel like I might be able to get some interesting clips. But yeah. Okay, anyways, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.